can you solve this algebra challenge? Here's the question. Given that x is a real number that satisfies this equation, x raised to the power of x squared minus 9x plus 20 equals 3 raised to the power of x squared minus 9x plus 20, then the goal here is to find all possible values of x. Now pause the video right now and see if you can answer this question. And of course, if you're done, post your answer in the comment section down below, because here's the solution in 3, 2, 1. Alright, so given this equation, the goal is to find the real value of x that satisfies this given equation. Alright, now, case number 1. So to answer this, we will need 3 cases. So for the case number 1, the base and exponent are the same thing. If the base and the exponent are the same thing, therefore the left-hand side and the right-hand side is technically balanced or equal. So in this equation, the base is 3, so x here is equal to 3. So that is the answer. If we replace all x with 3, then the left-hand side and the right-hand side balance, so x equals 3 is technically a solution to this equation. So for case number 1, our answer is x equals 3. Alright, now how about case number 2? So the case number 2 is when the exponent is 0. So when the base is any real number except for 0, then we raise this number to 0, then the equivalent is just 1. So if they are both equal to 1, then they are balanced. So that value of x is a solution to this equation. So now, let's get this exponent. X squared minus 9x plus 20 equals to 0. And let's find the value of x. Take note that we can factor this out nicely as x minus 4 multiplied by x minus 5. Now, since it is equal to 0, so at least one of them is equal to 0. So we can say that x minus 4 equals to 0 or x minus 5 equals to 0. It follows in the first equation x equals 4, and in the second case is x equals 5. So when x is 4, this base is 4, then the exponent is 0. So this is just equal to 1. And the left-hand side is also equal to 1 because we have here 3 raised to the power of 0. And the same thing in 5. So for the case number 2, we found another solutions, which is x equals 4 and x equals 5. They are both part of the solution. Now here comes the third case. So when we have a negative base and an even exponent, the result is a positive number. Therefore, we need to check also if x equals negative 3 is part of our solution. Because if we let all x be equal to negative 3, we have here negative 3 on the base, and the exponent is an even number, then the left-hand side is also positive number. The result is positive number. So let's check if the exponent is even. So let's have x squared minus 9x plus 20. Let's replace all x with negative 3. Now, simplifying this, we have here 9. Negative 9 times negative 3 is 27. Then add 20. 9 plus 27 is 36. Plus 20 is 56. So this is even. Therefore, negative 3 is also part of our solution. This satisfies also the given equation. Therefore, our answer to this question, given this equation x raised to the power of x squared minus 9x plus 20 equals 3 raised to the power of x squared minus 9x plus 20, then the values of x that satisfies this equation are x equals 3, x equals 4, x equals 5, and x equals negative 3. And as always, we are done.